Hello, I am Ben Moore and I will be trying out a new format for this series on GCSE chemistry revision. This should allow me to get them out on a more regular basis, but sadly they won't be able to feature the same amount of animation I've had in the past. Today we'll be looking through the AQA Higher Chemistry C1 GCSE paper from 2013. Question 1. Aluminium has many uses. An aluminium atom has 13 electrons. This also means it's got 13 protons. That would be its atomic number. Draw the atomic structure of the aluminium atom. Now the thing you have to remember here is you have 2 electrons in the first shell. Draw them equidistant apart. They basically repel each other. Like charges repel, think of trying to force the ends of 2 magnets together. 2 norths, 2 souths, they push each other apart. That's why you should draw your electrons in that manner. It becomes a bit more important when you go on to do A-level. For the minute, just understand that they push each other apart. So you put those in there. Next shell can take 8. That's taken up a total of 10. 2 for the first shell, 8 for the second, leaving you with 3 left over. Draw them equidistant apart, but I'd draw them in the quarters there for GCSE. Okay, moving on to 1A2. Name the 2 subatomic particles in the nucleus of an aluminium atom. Here you have a proton and a neutron. Best way to remember it is a neutron sounds like it should be in the nucleus. Those are neutral, and protons have a positive charge, which is why, when we look at our next question, why is there no overall charge on an aluminium atom? The number of positively charged protons is equal to the number of negatively charged electrons. So the nucleus has a positive charge because of the protons. The neutrons don't factor into the charge at all. They're there for nuclear stability. And the number of electrons will be equal if the atom is neutral. If it's an ion, if it's a negative ion, it's going to have more electrons. If it's a positive ion, it's going to have more protons. Okay, moving on to 1B. Rail tracks are made from steel. Molten iron is used to weld rail tracks. The reaction of aluminium with iron oxide is used to produce molten iron. So this is the thermite reaction. So let's have a look here. The best way to do this, and the way I did it when I was doing my GCSEs, is to create a tally on either side. So I'd write aluminium, iron and oxygen on the side, do it on both sides for both reactants and products, and then start totaling them up. To begin with here, you've got given to you on the reagent side 2 iron atoms. You can put those 2 in there, then you put 3 oxygen. Go over to the other side, what are you given? You're given 2 aluminium and 3 oxygen, so you go 3 into there. So oxygen is balanced, as you can see. Then you look at aluminium here, you'd have to put 2 on the other side to balance it, so plonk that in. 2 and 2. Have we got 2 iron here? Yes, we can put that in. Does that all balance? Yes, it does. Nice and simple. You don't have to get drawn into some elaborate thing where you're trying to hold it all in your head. Just draw a tally. It's very quick, very simple. Once you've done it loads and loads of times, it becomes stupendously quick. Maybe you'll do it in your head, maybe you won't. But if you start this way, it just helps you get into it. Okay, 1B2. Why does aluminium react with iron oxide? This is actually quite simple. Aluminium is more reactive than iron. When you look at the reactivity series of metals, aluminium is above iron, therefore you're going to get a displacement reaction. That's all we need to put in there. If you wrote a displacement reaction, you would have got the mark. I'm just going to put up the mark scheme so you can have a look at it yourself, see what the examiner puts in. I will also include a link to the original AQA examination paper. All of these are available online, freely available, with the mark schemes and examiner's comments. Can be very useful to read over those since they give you an insight into the questions. And sometimes it's quite nice just to know that other people found a particularly tough question to be challenging as well. Okay, I hope you enjoyed that. I'm going to have another one of these out in a few days, and let me know in the comments if there's anything you'd like me to cover or clarify. Hope you're doing well, and good luck with any exams you may have.